All right, we're back. And in this video, we're going to talk about factoring trinomials. So this is, when a lot of people think of factoring, this is, if you've seen factoring before, this is what your mind might go to. So this is where we have typically a quadratic, so second degree trinomial, three terms, second degree. So like an x squared term, an x term, and a constant. And what we're trying to do is factor this as a product of two linear binomials. That's really the general theme. And there's two ways that I'm going to show you to do this, and you should be familiar with both of them. The first way is going to be a way that will get you to the answer very quickly if it's something that's an easier type of trinomial. So if the numbers are not too bad, then you can do it the easy way. And you need to be able to do it this way because these types of trinomial factorings come up so often in problems as you go on to intermediate algebra and pre-calculus and, you know, any kind of classes you take later, that you're going to have to be able to do it quickly. But if it's a trinomial where the numbers are not so small or not so nice, and you still need to be able to factor it, you don't want to spend all day just, guessing and not being able to see what's going on, and you just end up wasting a bunch of time. So you do need a step-by-step process for going through it as well. And then you need to be comfortable with both of these. And then when you see a polynomial, a trinomial, decide, am I going to try and do it the quick and easy way and take a chance, that I can get it quickly? Or am I going to do the step-by-step way and take a little bit longer? Or maybe I do the guess and check and it doesn't work out, and so I end up having to do the step-by-step process anyway. But in any case, we're going to go over both ways. So let's start with, okay, this was the previous. So let's start with some simple examples. Whoops. So this is going to be some guess and check. So the idea behind guess and check is exactly what it sounds like. It's really trial and error. So what we're doing is we're saying, we know kind of what the form is going to look like. So why don't we just fill in as much as we can? So we know this has to be like this has to be like this, and then just kind of guess on what's left over. And hopefully with our intuition, and maybe we guess two or three times, we're able to come up with the right numbers and the right pattern of pluses and minuses. And then you check it. So you have to check to see that you got the right factorization. So start with four different examples. Okay, so let's look at x squared plus 5x plus 6, x squared minus 5x plus 6, x squared minus 5x minus 6, and x squared plus 5x minus 6. So notice here, we've got all of the different possible combinations of plus and minus for the term. So it's always x squared here. We've got all the different combinations of plus and minus for the last two terms, plus plus, minus minus, minus plus, plus minus. Now we know that for all of these, if they're going to factor as a product of binomials. So they're going to factor like this. So they're going to be, x something times x something. So the first thing you want to ask yourself is, well, what does the pattern of the signs have to be? So what does the plus minus pattern have to be? The important thing here is that this second sign, so the sign that's attached to the constant term, the last term, this one, this tells you whether the signs are the same or different. So are the plus minus the same or different? So let me show you exactly what I mean. If this sign here is positive, then they're going to be the same. So this is going to be, since this is positive, this is going to be same sign. It's going to be the same. But if it's negative, you're going to have opposite signs. So I guess I should say same. Another way to put it is just opposite. Okay. So if the sign is negative, then it's going to be opposite. Now, since it's x and x, so it's not like one of them's 3x, the other one's 2x. Plus minus is really going to be the same as minus plus because you could change the order of the factors and it doesn't really change anything. So once we see that it's going to be the same sign here. Now, first of all, why is it the same sign? Well, it's because positive times positive is positive and negative times negative is positive. So if they're the same sign, they'll multiply together to make positive. If they're opposite signs, they'll make negative. So it's really just the pattern of how positive and negative numbers multiply. Sorry, that still bothers me. Okay, so the other one is positive times negative is negative, negative times positive. Of course, then is negative as well. That's why we get this. So here, we know this has got to be the same sign. Now, which sign is that? Well, that's how you tell. So in the case that it's the same sign, then you look to these and that tells you which sign. So here, positive, the second positive tells us they're going to be the same sign. And then we look to the first sign that says they're both going to be positive. So here, the plus 6 tells us the same sign. And then we go to the minus 5x, though, and that minus sign tells us they're both going to be negative. So they're negative, negative. Now, for the opposite, we don't have to look anywhere. So we don't have to look here to see that it's going to be plus, minus, plus, minus. We will look there to see about the numbers, how we place the numbers, but we don't have to worry about just the signs for now. Now, it's just a matter of filling in the numbers. And for this, what you want to do is look at, the last number here. And these two numbers have to multiply to this. So you're really looking at all the possible factorizations of 6. So here, there's really only 2 of them. There's 1 times 6 and 2 times 3, up to the order of the factors. So is it going to be 1 and 6 or 2 and 3? Well, let's see. If we try 1 and 6, now this is the check part. If you FOIL this out, you multiply out x plus 1, x plus 6, that would be x squared plus 7x plus 6, because the 6x and x combine to make 7. Well, we want 5. So that's not going to work. So there's only one other possibility, 2 and 3. And if I try 2 and 3, this does multiply out. This FOILs out to x squared plus 5x plus 6. So that I'm done in this case. The same thing for x squared minus 5x plus 6. If I were to try 6 and 1, I would get, if I were to try to 6 and 1, I would get minus 7x. But if I do 2 and 3, I get x squared minus 5x plus 6, which is correct. So. Now let's look at the one with the opposite signs. Now this is going to be different. I've got opposite signs. Now if I try 1 and 6, if I first do 6 and 1, so what I would see here is I would get x squared plus 5x minus 6, which is close, but this sign is off. So when that happens, what that tells me is I need to switch the numbers. So I should switch them out, use the same 2 numbers, but in a different order, 1 and 6. Another way to look at it is this sign, in the case of opposite signs, this one tells you, is there more positive or negative? So this says there's more negative than positive. So if they're supposed to be more negative than positive, then the minus sign should be attached to the bigger number 6 instead of the smaller one 1. So x plus 1, x minus 6. Sorry here. X plus 1, x minus 6. And this one, so now I look over here, and this one tells me I got more positive than negative. So which means that would be the 6, it would be positive 6 and a negative 1. And if you multiply that out, you do get, we got x squared plus 5x minus 6. So these are the 4 possibilities here. And it's what you're looking for. You always start with the second plus minus sign, and then you work your way backwards to the first one, just filling in as you go. Now here the number is pretty small. 6 only factors 2 ways. If the number factors a lot of different ways, say it was, I don't know. Let's see. Say it was 36. 36 factors a lot of different ways. Let's think. How many different ways does 36 factor? So if it was 36, it could factor as 1 and 36, or 2 and 18, or 3 and 12, or 4 and 9, or 6 and 6. So there's quite a number of ways that could factor. Actually, 6 and 6 you wouldn't have to worry about because that would show up as a special formula. We'll talk about that later. But this is the idea with guess and check. Notice here, the leading term was always x squared here. Whenever you have a leading term of x squared, so the coefficient, the leading coefficient's 1, you should always try guess and check because you automatically get, the x and x. And so you're really just looking for the pattern of the plus and minus in the numbers. That doesn't mean that if you have 2x squared or 3x squared or even 6x squared, doesn't mean you shouldn't try guess and check if you practice it and you get used to it. It just means that definitely if it's x squared, you should not be doing the step-by-step method if it's x squared. That's just not, it's not necessary to go to that. So let's look at some more examples. All right, so 12x squared plus 12x plus 11 plus plus. So if they're both positive, that means I know that I'm looking at a pattern of both positive in the factorization x plus something. Whoops, how do I do? Okay, so x plus something, x plus something. 11 is prime. So definitely this is, there's only one way that this could work. If it's going to work, it's going to have to be 11 times 1. There's no other way around it. So if this middle term was anything but 12x, if it was 9x or 13x or 3x, anything except 12x, this would not factor like this. And you would just say that it's prime. So that's option B, polynomials prime. So that's a possibility too. Maybe it doesn't factor. Okay, this one is similar, so I'm going to skip it. This turns out to be a special formula, so I don't want to do this one right now. Now let's look at this one, y squared plus 5x minus 14. So in this case, it's a minus sign. You look at the second sign first. So that tells us we have opposite signs. So we can automatically put y plus something, y minus something. We need our two numbers to multiply to 14. And whenever it's minus, so this is the other thing I didn't maybe point out. When you have the first case where they have the same sign, you're really looking for two numbers that multiply to this number and have a sum. They add to the linear coefficient. So for instance, with 5 and 6, you're looking for two numbers that add to 6 and, multiply to 6 and add to 5. That's going to be 2 and 3. If it's opposite signs, then you're looking for two numbers that multiply to that constant but subtract. They leave a difference of the linear coefficient. So you're looking for two numbers that multiply to 6 and subtract to 5. Well, that's not going to be 2 and 3 because they have a difference of 1, but it is 1 and 6 because they have a difference of 5. So you see the difference? That's the difference. So in the one that we were looking at, since this is opposite signs, minus sign, we're looking for two numbers that multiply to 14 and have a difference of 5. Well, 14 only factors a couple different ways. Clearly, 14 and 1 is not going to work, but 7 and 2 work. 7 times 2 is 14. 7 minus 2 is 5. You just have to make sure to get the order right. If I were to do 7 plus 2, y plus 2, y minus 7, problem with that is my middle sign, my middle term does not match in its plus minus sign. This foils out to y squared minus 5y minus 14. I want it to be positive. So that means I need to, well, you can think of it as either switching the numbers or switching the signs. Minus 2 plus 7. Now you've got 5y for the middle term instead of minus 5y. Okay, so if you want to pause the video, see if you can factor this. Just take like 60 seconds. All right, so in this one, 45 does factor a number of different ways. So you might immediately think of 5 times 9. 5 times 9. Now the sum and difference of 5 and 9, you can just quickly say, well, 5 plus 9 would be 14. That doesn't match. And 9 minus 5 would be 4. That also doesn't match. So you can rule out 5 and 9. Well, what other ways does 45 factor? Well, it factors as 15 times 3. And now you see, oh, right, I'm looking for two numbers that multiply to 45 and subtract to 12. 15 and 3 would do that. So I know that I have different signs. And I'm going to use 15 and 3, and I need more negative than positive. So that means the 15, the bigger number, needs to be attached to the minus, and the 3 with a positive. And if I FOIL this out, I do get x squared minus 12x minus 45. Okay, this just takes practice. Okay, the more you do of these, the better you'll get, the faster you'll get. X squared plus 35x plus 43. Now, we know this is going to be x plus x plus. Question is, okay, x plus what? Well, 43 is prime. So even though, this is what I mean about, if you look in the handout for the factoring steps, I talk about big numbers and small numbers, but I'm not talking about big and small in magnitude. I'm talking about big and small in terms of the number of factors. So how many different ways can they be factored? And although 43 is a relatively big number in magnitude for these problems compared to 6 or 12 or 30, well, 36 is about the same, but it looks like it's bigger than any number we've seen before. But in fact, it's really quite small because it's prime. So it doesn't factor very much. The only factors is 43 times 1. So if you do 43 and 1 or 1 and 43, this is the only way it can work. And clearly this doesn't work because it is going to FOIL out to x squared plus 44x plus 43. So if it was 44x and not 35, we'd be okay. But it's 35. So what we can conclude is the only possible way that we could factor this did not work. So that means that it has to be prime. So this polynomial simply does not factor into two linear factors like that. Okay, so we call this an irreducible quadratic. Okay, same thing here. So you see, oh, 7, that's either going to be 7, it has to be 7 times 1 because 7 is prime. 7 plus 1 is 8, 7 minus 1 is 6. Neither of those match 5. So you don't even have to think about the signs really. As soon as you see it's prime, you see, well, it's going to be 8 and 6, and neither of those match. So it doesn't matter what the plus minus stuff is here. This is always going to be prime as long as 5 is the middle coefficient. So that's prime as well. Okay, now let's look at this. So this one is one that I would suggest trying guess and check, even though it's 5x squared. It's 5x squared plus 18x plus 13. So let's look at this. Now, the reason that I say that this is okay to do, it's not going to be too bad, even though it looks really bad. If you look at it, it doesn't look like something that you'd want to do mentally, that you'd want to do in your head, or want to do it with the fast guess and check. But it has a number of things going for it. What does it have going for it? Plus, plus. So I know I've locked in those signs in particular. So I guess the key is that this one is positive. If that second one is plus, that means it's good for guess and check. Why? Because you've locked in the signs. You know it's going to be plus, plus, or minus, minus, and you don't have to worry about how those signs are going to turn out. Also, if you look at the first and the last coefficient, so the leading coefficient and the constant, 5 and 13 don't look too great. You're really looking for x squared over here. You really want to see just 1x squared. Well, I don't see that. And you're really looking for a small number for the constant. So I see 13. So that might not look too good there. However, these are both prime. So in fact, these are not really big numbers. These are as small as you can get, in the sense that each of them can only be factored one way. So if these are prime, that's also good. That indicates that it's good for guess and check. So we've got a number of things going for us here. In fact, we can automatically write down that it's going to be plus, plus, and 5 only factors as 5 times 1. So we've got 5x and x there. The only thing left is to figure this. And since 13 is prime, it's either going to be 13 and 1 or 1 and 13. So there's only 2 possibilities. Now, if you look at 1 and 13, so if I put 1 and 13, the 13 is going to hook up with the 5. They're going to go out on a date and make 65. So that's not going to work. So really, we want it the other way. And I went 13 and 1. And this now works because when I do the outer and the inner makes 5x, the inner makes 13x, and the 5x plus 13x will combine to make 18x instead of 66x, I guess it was before, which does match. So that's a match. Great. So this is the correct factorization. So this worked pretty good, guess and check. 5x plus 13, x plus 1. Okay. See if there's another one here that's not too bad. This is another one that I would say you should try guess and check. So let's think about what it has going for it and what it doesn't. Again, it's got the second sign there is positive. And also its outside coefficients, the leading coefficient and constant, are 2 and 19, which are not 1, but they are prime. 2 is prime, 19 is prime. So I can immediately say, oh, this has got to be 2x minus something, x minus something. So it's just a matter of, is it going to be 19 and 1 or 1 and 19? And if you mentally FOIL out those 2 possibilities, you'll come to the conclusion it should be 1 and 19. That will FOIL out to 2x squared. Sorry, I did it just the opposite. If I did it, okay, so let's say you did it this way. This would FOIL out to 2x squared minus 39x, because the 19 times 2 is 38, which does not match. So we try the other way. Let's do 19 here and 1 here. Now it's 2x squared minus 21x plus 19. And again, if neither of those two worked, then I would conclude B, that this is prime. Okay, this one now, this is starting to get on the border of where you might want to do it by the step-by-step method. It does have positive there, and 3 is prime, so that's good. But the 8 can be factored a number of different ways. So that's gradually increasing the number of possibilities to check. But this still isn't too bad. It's either going to be 8 and 1 or 4 and 2. So let's look at this. So is this 8x squared minus 10x plus 3? Oops. Sorry about that. Minus 10x plus 3. Okay, so again, put in everything that you know you can put in here. I know it's got to be plus minus. Actually, that's all that I know so far. Sorry, it's got to be minus minus. Minus minus. And then 3 only factors is 3 and 1. So this has got to be 3 and 1. So actually now we're quite a bit of the ways there. It really only matters about these two. Is it going to be x and 8x, or 8x and x, or 4x and 2x, or 2x and 4x? So see what I'm saying? There's 4 possibilities here to mentally check through. Now, hopefully, so if you try these different combinations, let's see what we would get. If it's x and 8x, okay, we get 24 and 1. There's no way that can make 10, so we could rule that out. Okay, so what I'm doing is I'm mentally placing these two terms here. I mentally FOIL these out. So you have to do this in your head. So this is why it's good to be able to FOIL out binomial pairs like this without writing anything down, just being able to do it completely inside your brain. So this would give us a middle term of minus 25x, which obviously does not match. So we can rule that out. I could try it the other way. 8xx. Now I've got 8 and 3. Still, that makes 11. Doesn't match. So that's no good. Okay, well, still we can't say that we're done yet because 4x, 2x. Let's try 4x, 2x. What does this give us? 4 and aha. We've got a minus 4x and a minus 6x. That seems to work. Success. So notice, what I'm going through here is kind of something that if you have some facility kind of doing this mentally and inside your head and be okay. But this would be perfect. This would be one that would be okay by guess and check, but it'd be also okay by the AC method, the step-by-step method. I'll show you in a minute. In fact, I'll go back and show you how you can do this if you don't want to try and do it by trial and error. So in any case, we get 4x minus 3, 2x minus 1. Okay. I don't really want to do any more guess and check, but I want to show you something that can happen. Okay, let me go back here. So, let's see. Actually, give me just a minute. I'm going to pause the video for, there's an example I want to think of, but I need to take just a minute to think of what that example is. So I'm going to go ahead and pause this. I'll be right back. Okay, so here's an example. It's not the only one, but so something like this. 6x squared plus x minus 2. Now, let's just go through and well, I'm going to write out. I'm not going to do it mentally, but let's just write out. Let's say you started with 6x x. So you thought, okay, I could do it this way. I know it's got to be minus here, so it's got to be opposite signs. But let's just think about where the factors of 2 could go. So what I claim is actually that I'm kind of forced here. It can't be 2 and 1. Do you see why it can't be 2 and 1? Just go ahead and think about that. Pause the video or just think about that for a second here. I'm saying this is impossible. So why is that? Okay, so here's the reason. Look at this factor. There's actually a common factor of 2 there. In other words, I could factor, if it factored this way, I could factor out a 2. 2, 3x, and then, plus minus 1. Doesn't matter what the sign is here. I could factor out that 2, and 2 would end up being a factor of the entire thing. So this would be a factor. It would be a GCF factor. But look at the original trinomial. Look at the middle term, plus 1x. So the GCF is already factored. So this is why you need to do the GCF at the beginning. If you factored out that GCF, then you know that when you do this little thing, I can eliminate 2 because it would make a factor of 2. But I know there's no factor of 2 because I already factored out the GCF and there's no, the middle term is not divisible by 2. So that can't be. So if it's going to be this way at all, it's got to be 1 and 2, not 2 and 1. It's got to be 1 and 2. So if you didn't quite get that, you might just go back 3 minutes in the video or so just to listen to it again. It's really important that you get what I'm getting at here, because you can really save yourself some time. So once I know it's 1 and 2, now I can look at these two numbers and say, well, that's 12 and 1. And that's either going to make, it doesn't matter the sign, it's either going to make 13 or 11. So I'm trying to get 1. So that obviously does not work. So all this is not working. Okay, the only other possibility is 3x and 2x. And once again, since 2, I'm trying to place 2 in here, it could not be 1 and 2 for the same reason. So you're able to eliminate possibilities without really doing any calculation. I can eliminate the 1, 2 here simply by the fact that I would get a common factor of 2 here, and I know that that's impossible. So if there's going to be something that works here, it's got to be 2 and then 1. And in fact, I can do this because I'm trying to get positive 1. So I want more positive than negative. So I'm going to put the positive here because it's going to make a positive 4x, and the negative here will make a negative 3x. So 3x plus 2, 3x plus 2 times 2x minus 1 will give me 6x squared plus x minus 2. So this is the correct factorization. Now, again, you don't have to do this by guess and check. You could do it the step-by-step way I'm going to show you in just a minute. But be aware of that. That's some way that you can eliminate possibilities and allow you to do these a little bit quicker. All right, so it's time to go over the AC method. So before I get started, let me say this. Not most of you, but a lot of you may have seen some algorithm or way of going through this to factor these trinomials that you were taught by someone else, or there's a way that you were taught to do it that may look slightly different from what I'm going to do, what I'm going to present. And so my thoughts on that are, if you've learned a previous way and it works for you, and you can do it consistently without making mistakes, then I'm not going to force you to do another way So I'm not going to force you to adjust to my way to do it. I mean, I can't do that online anyway, but even if it was a written exam with paper, pencil and paper, I'm not going to force you to do that. But that's if you're able to do it correctly and consistently. I like the way that I'm going to show you to do it for a couple reasons. So first of all, it's because a lot of people do this ninja thing or whatever. I don't know. There's different ways to do it. The reason I don't like this kind of thing, this is just kind of me getting on my high horse here. The reason I don't really like this kind of thing is it obfuscates what's going on. It looks like a bunch of hocus pocus, and math is not about hocus pocus. It's not supposed to be a magic show. It's supposed to show you what's going on, and it should be giving you some insight into the steps. In other words, you should be able to follow it from beginning to end. And, maybe you could say, well, how did they come up with that? Or that's really clever, but it shouldn't be some big mystery like, oh, like I jumble around these numbers and magically this thing just seems to work. That's not really what math is about. That's not really how you should try and understand math. So what I'm going to show you, this AC method, may seem a bit longer and it might be a little bit more steps, but once you learn it, when you go through the steps, you can justify each step at each time and you'll see why it works. Because what we're going to do is take that middle term and we're really trying to unfoil. We're trying to see, well, what does this split up as two other terms so that we could factor by grouping. This is the combined, the OI of FOIL, right? FOIL is first, outer, inner, last. That middle term there you're seeing there is the combined outer and inner put together. So what we're trying to do is, in a sense, uncombine the outer and the inner. So we're trying to take the F, we're trying to take F, OIL. So this is what we have right now. We're trying to take this form of the FOIL and break this apart so that we really have first, outer, inner, last, and then we'll factor by grouping. Okay, so you have to go through that step to unfoil. But again, if you do this some other way and it works for you and you don't make mistakes with it, I'm not going to force you to do it this way. But this is the way that I'm going to show you. So what is the steps of AC method? So first of all, we're trying to factor ax squared plus bx plus c. It's called the AC method because we're going to use these two numbers, the leading coefficient and the constant, which are a and c. So it starts off, it says, okay, we find what I'll call the key number. Some people have different names for this. AC, which is the product of the x squared, so the product of the quadratic term and the constant. You just multiply those together. Now, I do the AC method even a little bit different than some people. I explain it a little bit different. A lot of people would say you try and find two numbers that multiply to AC and add to B. And then you have to keep track of the plus and minus signs, the signed numbers. Find two signed numbers, plus minus numbers. I think it's easier to do the following. Find two numbers, and so when I say two numbers here, whole numbers, so positive numbers, positive integers, that either multiply to AC and add to B. And this is in the case if this number is positive, you're looking at this. Or multiply to AC, so they're always multiplying to AC, and subtract to B. And in that case, you're looking at this one, this case. So notice this sign here tells you which case, whether you're trying to find a sum or a difference. So then when you find those two numbers, you use those two numbers to split up the middle term, the linear term. Doesn't matter what order. If you do this correctly, then either order should work. Okay, now you've got 4 terms. Now we factor by grouping. And that's it, you're done. Now, the key is at this step here, at number 2, find these 2 numbers. This is the hardest part. If you can't find these 2 numbers, so if those 2 numbers don't exist, then it's prime. So you can definitely conclude that this quadratic trinomial is prime. Okay, so we need to go over, how do we find these 2 numbers? Is there kind of a more rigorous process to do that? But let me start you with an example because this can seem kind of abstract at first. So let's go back to this 8x squared minus 10x plus 3. Now we did this by guess and check. But let's say that you were intimidated by guess and check, which is fine. Yeah, maybe you only like to do guess and check if it's x squared, if it's leading coefficient 1. That's fine. So here's what happens. You look at 8 and 3. So 8 times 3 is 24. So we're looking for 2 numbers, 2 whole numbers that multiply to 24 and subtract to 10, have a difference of 10. So think for a second, I'll give you like 10 seconds. 2 whole numbers that multiply to 24 and subtract to 10. Okay, so 24 factors a number of different ways. So you might think, oh, what about 8 and 3? Well, the problem is there, the difference is 5. So that means these 2 numbers are too far, are actually, sorry. Sorry. Let me back up. It's not the second one you're looking at. It is this one. Come on. To decide, because remember I went here. I'm sorry, I circled the wrong. Dang it. Okay. When you're deciding whether it's a sum or difference, it's the final plus minus. I was circling the wrong one. It is this one. So if this last sign is positive, you're looking for 2 numbers that add. If it's negative, you're looking for 2 numbers that subtract. Sorry about that. I don't have time to go back and edit stuff out. So just cross that out in your mind, and we're looking at the second one here. So when we get to this one, we're looking for 2 numbers that add in this case, not subtract. So our 2 numbers that add to 24, multiply to 24 and add to 10. Well, you could think, well, 8 and 3. So 24 is 8 and 3. But unfortunately, those add to 11, so that's a little bit too big. So if our number is a little bit too big, we need to bring the numbers together, closer together. And so 6 and 4 is an obvious choice, and those do add up to 10. So 6 and 4 are 2 numbers that multiply to 24 and add to 10. So then what we do is we take this minus 10 and we split it up. So this will split up as minus 6x minus 4x, right? Minus 10x splits up as minus 6x minus 4x. And now we factor by grouping. These first 2, there's a 2x, and we're left with 4x minus 3. And then this one, well, it's 4x, it's minus 4x plus 3. So if we subtract a minus 4x minus 3. Remember we talked about the factoring at a minus. And then you have to remember the trick that we did in the previous video, where if it's just minus something in parentheses, it's really there's a secret factor of 1 there. So this will end up being 4x minus 3, 2x minus 1, which is exactly what we got earlier by guess and check. So this works. Now you might think, okay, that's great, but what if I had switched these two? What if I did 8x squared minus 4x minus 6x plus 3? Is that going to not work? Well, actually, it still works, because in this case, I can factor out 4x and I get 2x minus 1. And then I could factor out a negative 3 from that and get 2x minus 1. So now I have the 2x minus. So you see, I just have the other factor in common. 2x minus 1, 4x minus 3. The order of the linear factors doesn't matter. 4x minus 3, 2x minus 1 is the same as 2x minus 1, 4x minus 3, the same way that 5 times 7 is the same as 7 times 5. Okay. Well, let's look at another example. We did, sorry, my allergies are sky high today. 6x squared plus x minus 2. Let's look at that. Plus x minus 2. Okay, so now we look at 6 and 2. 6 times 2 is 12. So that's our key number. And so we're looking for two numbers that multiply to 12 and have a difference, though. Have a difference of 1. So they have to subtract to that middle number. Right? That's what AC says. Multiply to AC and then either add or subtract to B. The reason I like this better is you're always working with whole numbers. So otherwise you have to think, well, they multiply to positive 12, multiply to negative 12, but add to positive. You just have to, constantly be thinking in terms of signed numbers. And to me, it's just more cognitive burden versus just thinking about whole numbers. So multiply to 12, subtract to 1. Well, what's going to do that? Well, 4 and 3. Sure, those multiply to 12, they subtract to 1. So that works. So we're going to split this up. How do I split up x using 4x and 3x? Well, it's going to be plus 4x minus 3x. And now I factor by grouping. 2x, 3x plus 2, minus 3x plus 2. So I'm factoring out a negative 1 from both of those. And so I get 3x plus 2, 2x minus 1, which is the same 3x plus 2, 2x minus 1 that I got before by guess and check. Okay. So let's just go through just a couple more examples. This just takes practice. Now, actually, here's a side comment. So when you see these patterns of two variables where it's like one of them squared, and then the mixed term, and then the other one squared, just do it like normal. You just have to put b, you have to put the other variable into that. So what I'm saying is, if there were no b's here, if there were no b's here, it's just a squared minus 13a plus 36. You could do guess and check pretty quickly and see this has got to be a minus 9, a minus 4. That would be a squared minus 13a plus 36. But because there's the ab and there's the b squared, that just means we have to add the b's back in. Bzz. Bzz. Okay. And now if you FOIL this out, you see you get a squared minus 13ab plus 36b squared. So it's really not anything new going on. It's just that you have to change the appearance of the terms. You have to make the terms have those factors so that they match up to give you the factors in the terms in the trinomial. Okay, let's go on one where it's really let's see. Okay. Actually, let me see what's coming up here. Okay, there's some negative ones. Okay. Let's say we're looking at one where the numbers are quite large. And actually, I'm going to pause the video again to think of the example. There's an example I have in mind. Okay. Okay, so let's look at this one. So the numbers here are quite big. We're looking for two numbers that multiply to 72, right? 9 times 8, and add to 22. Now that's something that may not be obvious. So what do you do if you don't want to be just hunting around for these two numbers? So here's what you want to do. You want to list the numbers on one side of a little table and then the sum on the other. So here's the key. Always start with 1 and you work your way up. Never start with the big numbers and try and work down. So we're going to start with 1 and 72, right? Those are the two most extreme ones. We're starting with the smaller factor and working our way up. So 1 and 72. That would give a sum of 73. Way too big. We went 22. So that's just, we have to bring them in closer. So we can bring them a little bit closer. Well, I increase 1 to 2. Okay. And I increase 1 to 2. 2 and 36 would make 38. Still too big. All right. So I keep going. 3. So notice I'm increasing the lower factor. 3 goes into 72. It goes in 24 times. And that gives us 27. So we're getting there a little bit by a little bit. And then the next one, I would hit 4. And then 4 goes into 72 18 times. Like 40 and 32. So that, and those add up to 22. So jackpot. So that tells me my two numbers are 4 and 18. So now I can proceed, to do this. Minus 18x plus 8. So I can do x, 9x minus 4, minus 2, 9x minus 4. Okay, so I get 9x minus 4, x minus 2. Okay, that's not the important part. The important part is if you're trying to search for these numbers, this is the way systematic way you can do it in this type of table here. Now, what if I gave you a slightly different one? I give you 9x squared minus 21x plus 8. Well, now I would do the same table, really, because it's still adding up, right? So I would look at this. I'd say, okay, 1 and 72, 73, so way too big. 38, too big. 27, too big. Then I get to 22, still too big. So I would do the next one. Now, the next one, I'm going to skip over 5 because 5 doesn't go into 72. 72 is not divisible by 5. So actually, I skip over 5. And I go straight to 6. And I get 6 times 12. That gives me a sum of 18. Now, notice what happened. Notice in this pattern, these are always in order, 73, 38, 27, 22. So they're decreasing. If you start on the outside, the most extreme factors, and work your way in, it's always going to be decreasing. So as soon as I get to 18 here, actually, I can conclude that it's prime. Why? Because if 21, if that's what I'm looking for here, 21 would be here, but it's not. So since 21 is not there, it's just not there, that means it just doesn't work. I can't find those two numbers, and so I'm going to conclude this is prime. So 9x squared minus 21x plus 8 is prime. Now you have to be super careful here, because if it was 9x squared, well, let me go to an x. If it was 9x squared minus 21x minus 8, okay, so now I'm changing the second term. This one's positive, now it's negative. Now I'm looking for two numbers that multiply to 72, but I'm looking at their difference. So now I'd make the same table. I start at 1 and 72, but instead of listing the sums on the right-hand column, I would list the differences, 71. 2 and 36 is a difference of 34. 3 and 24 is a difference of 21. And there it is. So see, you have to be super careful when you set up these tables. This one actually, then I could factor 9x squared minus 3x minus 24x minus 8. Plus 3x minus 24x minus 8. So this I could end up factoring as 3x plus 1, and then a minus 8, 3x plus 1. So 3x plus 1, 3x minus 8, which you can multiply out and see that you get 9x squared minus 21x minus 8. So that's just be aware of that when you're doing this, this is the way. If the numbers are really so big that you're having trouble finding them, or you're not sure that you can, that if they're there, and you need to do a really step-by-step way to try and find the numbers or show that they're not there, this is what you want to do. You want to construct one of these tables. Okay, last thing. All right, one last thing. Oh, just a second. So as I was saying, one last thing, always look out for GCF. This is a common theme we'll come back to. So something like this. So minus 12t squared plus 72t plus 84. So two things here. First, there's a minus, so we should factor that out first. So let's actually just take care of that, minus. But then also notice the 12, 72, and 84. There's a common factor there. The GCF of those is, well, it's 12, isn't it? Right. Yeah, 12 goes into 72 6 times, and it goes into 84 7 times. So there's a GCF of 12. So we should factor out minus 12. And this is something you'll see in a lot of problems. They'll throw you a polynomial to factor, but there's a GCF at the beginning. And if you forget it and you skip over that step, it's going to mess everything up from then. So you have to stop and think about it. So t squared minus 6t, and then minus 7. When you factor out the minus, you just change the signs of all the terms. Now, now you have to factor the trinomial. Okay, so this one is going to be what, 7 and 1 with minus 7 and plus 1. So negative 12, t minus 7, t plus 1. That is going to work. Okay, and I think that's pretty much covers all the bases on these type of trinomials. You can see there's other ones here. So these are ones that really have powers of the variable as part of the GCF as well. Yeah, so notice there's like they just threw in a random factor of a plus b, quantity a plus b in there. Okay, so that's basically we've covered that. So this is the trickiest bit of these factorings. In the next section, we're going to talk about so a few special formulas that come up over and over, especially to do with two terms, but also the perfect square trinomials. And these are patterns that when you see them, there's a formula you can use to factor them. So you need to really recognize them when you see them and know how to factor them. And we'll do that in the next video. And then once we're done with that, then we put everything together. So I'll just go through some examples. I'll probably just bring up some of the practice quizzes and just do some random problems.